Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 2685. Count the number of complete components. Okay. So what does the problem statement state? Problem statement states you are given an integer n. There is an undirected graph with n vertices numbered from 0 to n minus 1. You are given a 2D integer array edges where edges of I is equal to a comma b denotes there exists an undirected edge connecting the vertices A and B. Okay. Return the number of complete connected components of a graph. Okay. A connected component is something subgraph of a graph in which there exists a path between any two vertices and no vertex of a subgraph shares an edge with the vertex out of the subgraph. Okay. A connected component is said to be complete if there exists an edge between every pair of its vertices. Okay. So yeah, so let me summarize the problem statement. Okay, so let's take an example. This is the example which they have shared. Okay, so there are few things. Okay, firstly they have defined n is the number of vertices or the number of nodes. Okay, the graph contains these many nodes and all the nodes will be ranging from 0 to n minus 1. Okay, so if you see I have a graph on my left, it has the nodes from 0 to 5. Okay, so in this case n is equal to 6. Okay, so it has total 6 nodes and each node starts all the nodes will be in the range of 0 to n minus 1, which is 0 to 5. Okay, and they also mentioned we have been given an edges array. Okay, which will basically tell me that there is an edge between like you will be having an array of array. Okay, which contain two elements. Okay, so here they have been given like 0 comma 1, 1 comma 2 and 0 comma 2 and 3 comma 4. Yeah, that's it. Okay, so if you see these we have total 1 2 3 4 and we have 4 edges. Okay, so this is what they have been given. Okay, yeah, so and they have defined a property called complete. Okay, a graph is said to be complete if it has if the particular graph has let's say x number of nodes. Okay, then all the nodes should there should be an edge between all the nodes. There should be an edge between every pair of the node in that particular graph. Okay, if you see this is a subgraph which has 3 nodes in it. Okay, and if you see there is an edge between every pair of the node. Okay, if you take 0 and 2, this is a pair and there is an edge between them, and 1 comma 2 is a pair and there is an edge between them, and 0 comma 1 is a pair and there is an edge between them. Okay, and yeah, we have to identify all such components which follow this particular property. Okay, the first thing comes into my mind is to so if there are 3 nodes. Okay, and this node has to connect with each and every pair, right? So 0 has to be connected with 1 and 2, and 1 has to be connected with 0 and 2, and 2 has to be connected with 1 and 0. Okay, so if there are x number of nodes in my graph, each node should be connected with x minus 1 nodes. Okay, so all the nodes in this particular graph should have in its adjacency list it should have x minus 1 nodes. Okay, that means it should have x minus 1 edges, right? So each node should be connected with x minus 1 nodes. Okay, so that is the property. Okay, so what I will do, I will first create an adjacency list saying 0 is connected with 1 comma 2 and 1 is connected with 0 comma 2, 2 is connected with 1 comma 0, and 3 is connected with 4, and 5 is not connected with any of them. Okay, so for a given graph I will be labeling, so for each node I will be marking that it belongs to a particular set. Okay, so this entire graph belongs to set S1, this entire graph belongs to set S2, this entire graph belongs to set S3. Okay, so for additional to the adjacency list, okay, this is adjacency list. Okay, additional to adjacency list, I will also keep track of what all nodes belongs to a particular set. Okay, so I have a set S1 which contains 0, 1, 2. I have a set S2 which contains 5. I have a set S3 which contains 3, 4. Okay, so once I have prepared this thing, so I have to basically traverse through the elements in the set 1. Okay, set 1 contains 3 nodes here, right? And if this particular graph, if this particular graph if it holds the complete property, if I how can I say this particular graph is complete? If every node is connected to each node should be connected with all other nodes, right? So in the adjacency list of 0, it should have x 3 minus 1 nodes. Yes, it has 3 minus 1 nodes. In the adjacency list of 1, it should have 3 minus 1 nodes. Yes, it has. In the adjacency list of 2, it should have 3 minus 1 nodes. Yes, it has. So I can say set S1 is complete. Okay, in the similar way I should also do for S2 and S3. Okay, so let me note it down what all tasks we should do while solving the problem. First is to create adjacency list, and next is to mark populate the sets with its nodes. Okay, that means set S1 has 0, 1, 2 nodes. Okay, set S2 has 5 nodes. Okay, so how can I populate this particular thing? I can either use BFS or DFS to actually populate all these things. Okay, I will start at a particular node. Initially I will say it belongs to first set, and whatever nodes can be reachable from this particular node. Okay, and all its neighbors, I will mark all the nodes to set 1. Okay, once it is done, then I will go to another not visited set, and then I will mark it with set 2, and so on and so forth. Okay, all I have to do is to just have this thing ready, and once it has been prepared, okay, for each set, okay, for each element, okay, each element in the set, right? So I can say each element of a set should have number of elements in the set minus 1 number of nodes. Okay, so this is basically the number of nodes in the particular set. Those many nodes minus 1 node should be present as part of its adjacency list. Each element of the set should have sets of nodes in adjacency list of the node. Okay, so yeah, now that we have understood what needs to be done, let's jump back to Leetcode and let's try to code it out. Okay, firstly we have to create an adjacency list. Okay, to create an adjacency list, let's define the adjacency list. Okay, a list of integer. Okay, I will define, let's have the name as neighbors. Okay, so yep, so for neighbors will be new array list. Okay, now for int I equal to 0, I less than n, write neighbors of new array list. Okay, now that I have defined an empty adjacency list or neighbors, now that I have to populate it. Okay, for int edge in edges. Okay, first there will be an edge between u and v. Okay, so these are the two nodes which are part of the edge. Okay, so edge of 1. Now that I have both the nodes, first I have to add v to the adjacency list of u, and then I have to add u to the adjacency list of v. Now that I have created my adjacency list, next is to populate the sets with its set with the nodes. Okay, in order to populate it, I will be using BFS as I mentioned. So for BFS, we should have keep track of what all elements I have visited so far, right? So I will have is visited array. Okay, so let's initiate is visited array with no boolean of size n. Okay, now that we have instantiated, so for each node less than n, if it is not visited, then I have to mark the node as visited and add it to the set, right? Mark and add. Okay, so it will take the node and it should also take the set id. Okay, so which set it belongs to. Let's have a set id is equal to current set id is equal to 0. So we'll just increment it and then pass, so it will be the first set id. Okay, so let's try to code that function mark and add. It is taking the node and it is taking the set id it belongs to. Now that I mentioned, I should keep track of the set id and the corresponding list. So it's basically map of integer and list, right? So let's try to have that int private map of integer and list of integers. Okay, nodes in the set. Okay, let's name it as the nodes in the set. Okay, so firstly I should instantiate, right? Nodes in the set is equal to new hash map. Okay, now that I have instantiated it, firstly I should add the current node to the set, right? Put in the current set I should add it, right? So the list of node. Okay, or yeah, new array list of node. Okay, now that I have I've created a array list which contains node as an element in it. Okay, now that I should have a queue. Okay, so queue of integer, okay, to be explored. These were the nodes which needs to be further explored. New linked list. So I will first add this particular node to the to be explored queue, and I should also mark the current node as visited. Okay, now while the queue is not empty, get the node from the queue. Let's have the node in process as to be explore dot poll. Now that I got the node, for each of its neighbors, right? For each of its neighbor, okay, neighbors of node in process. So that is what we have. Okay, for neighbors. Okay, if the neighbor is not visited, yeah, so 0 neighbors are 1 and 2, both were not visited, so I should mark I should push this node into the particular set, right? So nodes in set dot get the list and then add the current neighbor to the list. Okay, once we have added the neighbor to the particular set, we should mark it as visited. Okay, once we have marked it as visited, we should also process the neighbors of the neighbor, right? So I will also push it into the queue so that it should be further processed. Neighbor. Okay, now that the node has been marked and it has been offered as well, so once this entire processing is done, now that all the nodes will be pushed into the relevant sets, right? So for each set, right, for int I is set id is equal to 1, set id is less than or equal to current set id. So by then this entire processing is done, we will be having total 3 sets, right? So for each set we should actually check whether all the nodes in the particular set has the if the set has 3 nodes, so each set in its adjacency list should have 2 nodes, right? So that is what we have to check here. Okay, now the nodes number of nodes is equal to the nodes in, okay, just a minute. Yeah, so now that as I mentioned, for each node we should actually check, right? So firstly I should get all the nodes in the current node. All the nodes belongs to the current set. List of integers, the nodes is equal to nodes in set dot get nodes, what all nodes belongs to the particular set. So first I will get all the nodes and number of nodes is equal to nodes dot size, these many nodes I have in the particular set. Okay, so for each node in its adjacency list it should have n minus 1. Okay, so for int node in nodes, okay, if neighbors dot get, these are all the neighbors of the node. Okay, if the size of it, if it is less than the number of nodes minus 1, okay, that means the adjacency list has lesser number of nodes. Okay, that means it can't be paired with all the elements. Okay, so firstly we'll say that is complete. Let's have a variable as is complete as true. That means by default we'll assume that every node can be paired with all other nodes. Okay, if this condition is violating, that means it can't be paired with all other, a node can't be paired with all other nodes. Okay, so that means we'll break it here, is complete is equal to false, and we'll just break it here. If we found any one such node also, we can stop processing it. If is complete, if it is true, that means we found a complete connected graph. So let's have the variable called count is equal to 0, which will actually count the number of complete connected graphs. So I can increment the count. In the end I can simply return the count. Let's try to submit this. Hope there are no typos or something like that. Okay, Okay, what they're expecting as semicolon. Okay, it is not it should be if. My bad. As I said, typos, right? Yep. Yeah. Yeah. All the basic test cases were solved. Let's try to submit this. Okay. Yeah. All the test cases were also passed. Hope you have understood my solution, right? It's pretty simple. All we have to do is to apply BFS and mark all the nodes to the corresponding sets, and then just check whether each node in its adjacency list has enough number of nodes to pair, right? A set has three number of nodes, so 0 should be paired with two nodes. Okay, if 0 has two elements in its adjacency list, then it should be it can be paired with all its nodes, right? So that's all about this particular problem. Do subscribe to my channel for more such coding videos. Thank you.